Hello, my name is Csaba, and today I'm going to show you how to create dynamic and versatile wrinkle maps in Blender for any character, and then implement the same logic inside a game engine like Unreal for fully game-ready characters. We are building everything from scratch, from start to finish. This isn't one of my usual tutorials. I will talk a lot, because sometimes you need to understand the logic behind the things, not just copy and paste Node 3 or whatnot, so you can build your own ideas, explore new directions, or get inspired to create something even better. In this tutorial, I will cover a range of topics, including how to properly combine your normal maps or fix existing ones with additional detail with free blend file. How to non-destructively layer and edit diffuse textures using texture paint with a similar layering technique, just like in Substance Painter or Photoshop. How to use drivers, pose library, and more importantly, how to create and control masks to blend different maps dynamically. How to implement all this logic to Unreal with a full material node setup. How to blend multiple or infinite diffuse maps in Unreal, material functions, animation curves, and driver-based control setups in the engine. What you need before you start: a texture character with at least a normal and a diffuse map, ARKit shape keys which are driven through a simple control rig. I will be using Faceit for this. If you're unfamiliar with Faceit, I will leave a link here to my previous tutorial where I go over how to set it up. You can do the exact same thing with traditional face rig too, but since we are focused on game readiness, I'm not using deforming modes in the face. That said, I will also show you how to set up drivers for bone rotation or bone movement if you want to convert the logic. Just to clarify, I do currently have a facial rig running under the hood, but we won't be using it and it won't affect anything. I will cover optimization, LODs, and cleaning up necessary bones in the future video. This tutorial will get a bit complex as we go deeper, so keep a close eye on the nodes and follow along carefully. By the end, you will understand everything what's happening behind the scenes. With all that said, let's start this. First thing is to plan ahead, which includes that you need to look some references of wrinkles and gather a few on the areas where you wish to add wrinkles. The reason I said areas because this method can work in every space of your character, not just the face. But typically you would only want this approach on the face area. So I want to cover the whole area from top of the head all the way down to the neck. For that, I'm going to visualize how I'm going to separate the face into main parts like the forehead, the nose area, and the mouth area. And last but not least, the neck. You should too, because it can get confusing later on. Do a snip of your character and just draw some rough lines on where you would want the separation, and save down this picture. Now for each part, we need to create a normal and optionally but a highly recommended diffuse map. Just be aware, in optimal case, you would want to have a maximum of 3 separation, which means an additional 3 maps, not 4 maps like I will do it here. So you would combine the forehead, for example, with the neck, and then you would only have 3 separation all across the area. But for demonstration purposes and for easier understanding and workflow, I'm going to do the originally drawn 4 separation version. With that aside, let's break it down. So let's start with the easiest, the forehead. Here we have a total of 7 controls, widgets for moving. But as I mentioned earlier, this isn't a traditional rig, it looks like one, and yes, it's called Faceit control rig, but in this context, it's really just a controller for driving shape keys, nothing more. We are not using deform bones or skin weight on the face. We are simply triggering ARKit shape keys, which is cleaner, universal, and more export friendly for games. For example, these two on the side both activates the same shape key, brow, upper, up, right. And obviously, the same goes for the left. So we already simplified it to 5 widgets. And it's logical as well. Grab a mirror and try to just lift that outer part of your eyebrow. I'm not sure about you, but I definitely can do that. Besides reference images, yes, a mirror can be your best friend in this task when you want to check really specific movements, which otherwise would be hard to Google. Now we have to look ourselves what kind of facial expressions would trigger wrinkles on the forehead using these widgets / shape keys, and what kind of wrinkles is going to be that, if any at all. A surprise, a questioning, an anger, and maybe some sad puppy eyes. However, the angry expression is the odd one out, because you might think if you pull this down, that's it, that's anger. Well, not really, because again, use the mirror and try to do this exact expression. You will not be able to do this unless you frown your nose as well, even for a little bit. So anger should not belong in the forehead category, since the shape keys in this area won't allow to do a proper full anger face. This will belong in the nose map. We also can't just cramp everything into one map, since it will cross-contaminate each other if you want additional detail on top of one another. We'll also in smooth mode you won't be able to tell what's going on. So the boring stuff is out of the way, let's do some actual work. Let's first pose the face with some questioning look, raise both eyebrow middle ones to the top. On the character I only have armature modifier, I don't have any multi-res on it. If you still have somehow the original multi-resolution data of your character on which you baked the base normal, you can try to adjust that, but it's going to be difficult. Since I'm assuming you already did micro details on the character, pores, etc., you won't be able to sculpt these wrinkles without distorting your details, which will leave you with some erasing and redoing and so on. So I not recommend doing that, and you can actually just avoiding a 2-minute process that I will show you in this video. So just do a new multi-resolution data and start with 2 or 3 subdivision, depending on your character density, of course. We don't want to go full detail yet, so let's get into sculpt mode and use just very basic brushes for this, like the draw or inflate, and then use crease polish in between. And use both with very little strength. I'm not using my tablet for this, just my simple mouse. Don't be afraid, I'm not going to bore you with every detail as we move towards in the video, I just have to give you an idea, the logic behind it for the first time around, and then you will get the hang of it. So that's done, let's check it in material preview. If multi-resolution is on 2 or 3, this should not blow up your PC, but always do backup saves. In this case, save this as a forehead sculpt, for example. My approach is to do separate files for each multi-resolution normal we will do, so we can always come back to that file if we want to modify that multi-resolution later on, non-destructively. So this is one of the reasons I start with low subdivision level, so you can visualize how this will look approximately. Will also, if you're going on high sculpt for the first time around, you will give really high detail very fast. So it's better to start low and build it up from there. Okay, that's looking good for me. Let's raise the inner brow up as well and get back to sculpt and continue sculpting. And attach these wrinkles so they are all connected. Now this is a good time for references. Okay, let's move the brows down for that puppy eye feeling and give some really slight wrinkle here. Be aware that this should connect to the nose properly to make it realistic, but I will show you how later. Looking good. Now let's save it and crank up that multi-resolution. Now ideally to the level that you sculpted your base normal. Set the viewport to 0 now and let's refine it now. Okay, it's done. Now save again. This will be our forehead sculpt file. Pull out a UV window and a shader. Create an image, you don't need alpha, and depending on your original base normal, create the image. Mine was 4K texture, so I'm going with that. I'm going to save down that image as an RGB, 16-bit, since mine was 16-bit normal. Normals usually should be 16-bit, and select non-color. Select cycles, go down to the bake section, select from multi-res. In the shader, add an image texture, select the image we saved down, then select the character as well. Then hit bake. Let's save this image. So now this is my setup. I have a height map as well, but I'm going to unplug this now. It's not important right now. I will plug it back in the end. Let's just focus on the normals. If I now add the mix node between the two normals and change the mix node, it does what it should. It changes between the two normals. However, that's not good for us just yet because we only want certain parts to change, not the whole map. For that, we are going to create our first mask now. You can either create it through Vertex Paint or with a simple image with Texture Paint. It's up to you. For Vertex Paint, we don't need to create an image just yet, so we don't eating up extra space in the hard drive. In the shader editor, we can reach it through this node, color attribute. It's more optimized this way in Blender, but I'm going to save this down as an image soon, so this is just an additional cool trick I wanted to show you, while keeping the method non-destructive. So create it, name it like forehead _WM_1, leave it on black, then up here at the color, change this to RGB, then set green and blue to 0. And on the red, set it to 1. Now paint the middle part of the head, which will be the inner brow shape key / widget. Okay, now let's change the color again, but this time we are going with green, so 0 on the red, 0 on the blue, and 1 on the green. Now let's paint the sides to green. This is for that questioning facial I mentioned. Next, same thing with the blue, and this time I'm going to paint this lower part. Now let's check what we have here. In the shader, in the color attribute, select the one we just created, pull out the node and look for separate color. Get 3 mix color node. Get the red, plug it into the factor of the first mix node. Get the green, plug it into the factor of the second, and get the blue and plug it into the last one's factor. Pull them a bit away. Unplug this from the normal, get the result and plug it into the first mix node to the B socket. Get your base normal map and plug it into the A socket here. Now for test, plug this result into the normal color input and see what will happen. So this factor, just like before, still is the control point of the visibility of the wrinkle normal map. If it's 0, then it is the base normal. If it's 1, then it is the wrinkle map. But now what's happening is that it is running through another mix color, which controlled by the red color mask. we created. Imagine this mix nodes factor as it is always 1, because basically that's exactly what is happening. We just cannot see it numerically, but it is only 1 in the red painted restricted area. On the other parts of the mesh, the factor is 0, which means everything that is not red, the socket A dominates. I quickly can show you that if I'm going to the shading at the render pass, select normal, and I unplug the A socket, you can actually see what I'm talking about. In other words, if you translate that, that means that the B socket dominates here in this area, and this area's appearance is determined by this mix node result. So if the mix node is 0, on the red part of the mask, you will see the base normal. If it is increasing or getting to 1, then on the red part, you will see the wrinkle normal map. Everything else will remain unchanged. Let's change the factor to 0 for now, and let's combine the rest of the mask as well. Get 2 more mixed color nodes, connect the wrinkle map to the B socket of these mixed nodes, set the factor to 0, and here it gets tricky. Now you might think that you want to connect the base normal to the A, just like we did with the first node. Seems logical, but that would be a huge mistake, especially later down in the line, and it would cause a lot of trouble. We don't want to mix our base normal map anymore. We did it at the first node, we don't need any more of it. So instead of that, we will grab this result and plug it into the A. Grab the same result and plug it into the A here as well. Now from this mixed result, plug it into the B. Let's do this one more time. So result to both A socket and this result to the B socket. And the final result will go into the normal map. Now if I did everything correctly, we should see that if I change the factors, the wrinkles should appear according to the mask. Okay, that's cool, but now how should we make it dynamic or responsive instead of manually changing the sliders? Well, here comes the ARKit shape keys and the face it control. So what exactly did we use? These two, and this one. But that's a total of 5 value instead of 3 what we currently have. That means that we have to separate this mask into 2 separate masks, 1 for each side. So let's just do that now. Duplicate the vertex group or your existing image. Give them a suffix that represent left and right. Go to edit mode, wireframe, then select one side. Go to vertex pane, select vertex, set the color to black and paint the unneeded area. Go back to edit mode, go to select and hit invert. Then back to vertex, select the other attribute, then paint it black. Now we have 2 masks for left and right. Now in the shader, select all this, then duplicate it. In the color attribute, now select right and left. Get the wrinkle map color output and plug it into the B sockets here. Then let's repeat the process like before. So here, result to the A. Let's unconnect it from the normal to avoid confusion. Again, from the result to the A. And from the last result, connect it back to the normal map. To get it a bit organized, select all this and hit Ctrl G. Then hit F2 to name it. Name it forehead WM_L. Same on the other side. This one is forehead WM_R. Now select all of it and make a group out of it. With this little icon, you can get out of the node group, and with F2 again, let's name it forehead. Now it's looking much more better. You can re-enter the group with this little icon now, and let's set up the factors now. For that, we are going to use the already existing drivers from the face rig. It's a good idea to create a snip of your masks and put it side by side with your blender, so you don't get confused which color is responsible for which part. So the red one is the brow inner up, this one. Let's find that shape key, right click and copy as new driver. Now in the shader, let's paste the driver to the factor and let's test it. You will get that flash effect because the material is changing, but obviously you won't see that at the render. And there you go, the first dynamic wrinkles. Nice. Now in the shader, I highly recommend to frame these with Ctrl J, then with F2 rename them to the corresponding shape key. It will be really useful later on, because otherwise you will always have to go here in edit driver and look for the path, so you can see which shape key controls it. It's just a way easier to debug. If you misclick something, just make sure it really is the same, otherwise you just kick yourself in the foot. Let's add the others. So green is brow outer up right, copy as new driver, paste driver, Ctrl J, rename it, test it. Okay, same with the blue, this will be brow down right. Again, find the driver, copy as new driver, paste it, frame it, name it, and test it. Now same on the other side, I'm going to speed it up. And now if you test it, it just works as it should. Just an additional info, it's not really ideal what I did here regarding the brow inner up. You should not waste a color mask like I did here, because for brow inner up shape key, I could have just had one big red spot, either on the left or the right mask. So I would have a free additional red mask somewhere else. Ideally, as I said earlier in this video, I would combine this with the neck, but I wanted to show you that you can blend it this way as well. If you see harsh seams there, just use a slight blur or smudge brush between the lines in the mask. But basically that's it. That's it for the forehead. But we are not quite done with it just yet, since if you take a closer look, you can see that the base normal obviously disappeared in the wrinkled area, and the wrinkle map took over fully, which is working as it should, but I want my base normal as well to be visible. I mean those tiny details I created. Now it's just a blank normal with a few strokes of draw brush and creases. Now you can easily solve that. If you remember, I mentioned it's a 2-minute solution, but before we do that, it's better to just create the rest of the wrinkles as well, because that fix should be the last step for finalizing it. So I will get back to it in the end. From here on out, it's going to be a quite repetitive process, so I'm going to speed the process here and there. I'm going to talk about some important info, especially in the mouse area and the neck, since they are a bit different. But let's just move to the next area, to the nose. Before that, don't forget to save yet another. And now let's pose the character. I already know what I need, but it's totally up to you. So I want these 2 nose sneers. I want these 2 as well, for eye squinting, for left and right, and a tiny bit of extra for mouth smile, left and right. Additionally, use any other like cheek squinting, which ideal and would be even better. Cheek puff doesn't really give you any wrinkles if you try it on yourself, but cheek squinting can be good. Now let's use that multi-res just like before. It's better to leave it like this, like I did here, because then you can just go back to sculpt 2 or 3, then it's easier to erase the multi-res. I'm going to delete almost the whole forehead part and leave that little bit of detail at the brows. This is also what I mentioned. If you leave this, you have a reference point of where you should create the harder wrinkles for the nose sneer. So this way it will be connected properly. Also, don't forget, when you jump to a higher scope, use the erase multi-res to smooth out the forehead, because since I went back to 2, it will leave a few details there. Weirdly enough, it's not going to affect anything basically, because we will not use that as a mask part, so it will never be visible, but just for clarity, you should just delete these parts. Okay, so I'm going to skip ahead, and this is the final result for the nose. I baked it down and saved this file as a wrinkle nose. And these are the 2 masks I created for it, one left and one for the right. So the best thing is that we already did the heavy lifting. We just need to duplicate this node group. Click on this icon to make it separated, rename it to nose. Inside the node group, switch the normal to the nose normal, change the vertex group, and rename the frames accordingly. Delete the drivers and replace them with different shape keys. In my case, nose sneer right, nose sneer left, eye squint left, eye squint right, mouth smile left, and mouth smile right. So this is the final one. And now just simply connect the first result and the vector to the nose, and the nose result to the normal. Test it. Seems it's working just fine. Let's quick jump and do the same with the mouse now. This was the mouse setup for the mouse and the normal. The normal is already baked down, and that's a bit different and more complicated. So I'm going to slow down here a bit. This one has to be planned very well before you do it, since it will require at least 2 more masks. So a total of 4 masks for only the mouse area. This one is a bit different in a way that you have to precisely think how you are going to create your mask, since it will be a lot more controls and a lot more overlapping controls, which should work individually as well as together. And colors can cross-contaminate each other inside one mask. I use a simple paint, for example, to just simply thought out the process beforehand. So let me show you the logic. So this should be the 4 masks that I draw. You can try out these in front of a camera or before a mirror. There are a variety of different movements that going on here. Let's first check one side. If you lift this one up, it should trigger some wrinkles. If you brought this down, it should trigger as well. If you do both, it should as well. If you do a full smile, it should as well. If your mouse goes left or right, it should trigger as well. If you frown, which means the opposite of smile, yes, it should activate as well, but in a bit different than the smile. Like leave out this little dent here. When you bit your lip, it should create some harder seams on the mouth, for example. If you do a duck face, which means a pucker here, it should create yet another one. And it's the same on the other side. You can see that when the mouth moves right or left, there will be a little bit of wrinkle on the chin as well, as it stretches towards the mouth. So it has to be different and only shown when the mouth goes right. I know it might seem overwhelming at first, but if you experiment with it yourself, you will realize that's what I'm talking about. Mistakes you do in the run is a good thing, you can learn a lot from them. I'm not encouraging you to screw it up intentionally, just saying, because this is the good place to screw it up. When you sculpt it, it's better to just create a pose after pose. I know it can be annoying, but it will be less confusing in the sculpt process, at least for me. So you, for example, pose it when the mouse is left, pose it when the character smiles, when it frowns, or when she's biting his lips. Now let's set up the logic again. Duplicate the node tree, click on the icon and name it mouse. Now we need 2 more of this. Name the frames correctly. Really important to call them the right name. Check it twice, check it 3 times, check it 4 times. Just make sure 100% that you name it correctly. You don't want to find yourself debugging only to find you just screwed up the name. Replace your normal with the mouse normal. Change the color attributes. And delete the drivers. You can add the reference image inside Blender or just beside your Blender as an image. So I know this group is the first one, which controlled by the following shape keys. Red, mouse, lower, down, right. Green, mouse, smile, left. Blue, mouse, upper, up, right. You can also use the reroute function to make it more tidy, and with G you can move this. Next, the Wrinkle Mask 2. If you are not sure which widget triggers which shape key, you can reset all location and rotation, and then just use that one widget. So this is a mouse smile right, for example, and I can see that it is on 1, so this will be the right shape key. The reason I say this, if you decline the smile, we don't need the smile shape key. We need a mouse frown shape key. As I mentioned numerous times, this is just only controls the shape keys. It's not a rig. So we have shape keys for the frown. That's what we are going to use, and not a smile driver with inverted logic. Now really precisely set the other ones as well. And let's test out all of it and let's see if they are working or not. Okay, seems every one of them is working. And now we can move on to the last one for the neck. Neck is more like a muscle movement than a wrinkle, but it's going to be here anyway. So for this, there will be only one mask I create, but I think you got the idea that you can do as many as you like now. This one is different than the others because this one will be not driven by a shape key, since ARKit only covers facial motion. Instead, this will be driven by bone movement. But for that, it is a good idea, before even sculpt, to create some pose assets for your neck. Again, this is optional, but this helps you prevent problems with the deformation. The whole neck wrinkle will be driven by the head bone rotation. For example, when it's rotating on the Z-axis by plus 40, then this sternocleidomastoid muscle, hope I said it right, will become visible. But if you just twist the head bone, it's not really realistic. The neck bone should move with it, but it's highly depending on your weight paint of these bones. But my take is to create it exponentially. So for example, rotate the neck 1 bone by 10, the neck 2 by 20, and the head by 30. This gives me a realistic head rotation, and I wanted to sculpt the muscle this way. Since I don't want to do this every time, I'm going to create some pose assets. To create poses, open up 2 windows, one dope sheet and one asset browser. Go to pose mode, rotate the bones you wish to pose, select the bones you deformed. In the asset browser, select current file instead of all library. Then in the dope sheet with N, you will able to see this side panel and you will able to hit create pose asset. If it's on all libraries, this button will be grayed out. So once I hit that, it's going to be visible now here. And I can call this command anytime if I double click on it. Just a side note, the thumbnail is depending on the camera in your scene, the active camera. So my active camera is looking straight to the character. That's why I have this super thumbnail. Now let's create the opposite one. Now let's create the up and down as well. Now it's all set and done. I'm going to keyframe them, then sculpt my neck multi-res now. Break it down and create the mask. Now this is the mask I created and this is the normal. So the two muscles and the little wrinkle under the chin. Let's set up the driver now. I just duplicated the forehead group, renamed it and so on. We already done this before. So here at the factor, we can't copy drivers. Now instead, we are going to create one from scratch. Right click and add a driver. Leave it unscripted. Select your armature and select the controlling bone, which in my case will be the head. Now for the rotation, it's best to check because it can be confusing if you pose it with the global gizmo, like I did here. Go to pose mode, select local, and check which axis are you deforming. So instead of Z, which was originally the axis in the global, now it is X on the local. So this is what we are going to use, the X axis. Go back and hit edit driver, select X rotation, and select local space. Now for the expression, this is what you should type in. This will be down below in the description for copy and paste. What's happening here shortly is we have to convert rotation to radians in Blender. It's a bit confusing, but this is how it is. And with 0 and 1, we are limiting it between 0 and 1. Let's test it if it's working. It is, so I'm going to copy these drivers and paste it to the opposite version and just remove the minus before the 30. Test it. Looking cool. And the last one is the wrinkle below the chin. Check the local rotation. It is the Z. And in this case, I rotated it with minus 20. So I'm going to type that. Now it seems like we are done with this. In this point in time, it's a good idea to create a face range of motion animation, in short, a FaceROM. You can see that animation in the beginning, but it's not covering technically all the possibilities. It shows around 90% of it in a nice motion, while keeping it a bit realistic and less robotic. But this is optional and not necessary at all. It will help you identify problems if it has any. That's why I found it a good idea. However, an actual full FaceROM would be to key every single frame, with each frame showing of one shape key. When you are creating a face rig with Faceit, there is an option for this. If you check the video of mine, I didn't use it, but you can, and you can save it down as a separate action or create it from scratch. Actually, that's one of the steps to create a face control rig in Unreal Engine, but I'm not going to get into that now. Now create the FaceROM, and as I can see, no bugs occurred, everything working great. Now it's time to finalize these normals and masks. So for the normals, as I mentioned, we want that tiny detail on top of our wrinkles. But there is a 2-minute solution for you. I prepared this normal combiner project file for you. You can download it free. It's down below in the description. This node setup is based on this fine gentleman's work. Give him a like and a sub. It's extremely great. I used it quite a few times. It basically mathematically combines the two normal mobs in a correct way. You can watch his video. It's really informative regarding this topic. But if you are not into that, the only thing you have to do here is open this file, place your base normal to the base and extra to the extra. You can control the strength of the other normal here, but I'm going to leave it on 1. And you just have to hit render image, and after a few seconds, there you have your combined wrinkle map with your base map. I wanted to create an add-on out of this. If anyone is up for the task, I have a rough sketch. Feel free to contact me. So you just have to bake down each of your map like so. Once you did that, you just switch it out in your project, and voila, it's looking much better. Now for the mask, this is how you bake them down to a simple image. If you use Vertex color like me, unconnect your node, get the color attribute and the diffuse node. Connect them up. And one by one, we are going to bake them down as a diffuse. Again, make sure cycles is selected, go down, untick multi-res, at bake type select diffuse, and make sure direct and indirect is unticked. You probably need to deattach the head for this process if you have more materials on the whole body and get rid of the additional materials, but we only need the images anyway, so we can reload our file later. Now pull down a window, select UV, create an image, make sure alpha is checked, and make it 2K. Mask doesn't have to be a high definition, just relatively to not pixelate it. So once that's done, get an image texture, select the texture we just created and hit bake. save it down. Now repeat the process on all of it. Once you've done it, you can switch all color attributes to a texture one. If you're just using it in Blender, this method is not necessary at all, but for Unreal we are going to need that, and I just like to keep this organized, so I'm going to use images here as well. If you need to correct the mask, now you can correct it through texture paint. For that, go to texture paint, and here make sure you select single image. Find your mask you want to edit, make adjustments. In the UV window, select this exact same image, and once you're happy with it, you can save it down. Oof, quite a long run. Actually, we are fully done with the normals. If you're happy with this, you can just leave it like this. But to lift it to another level, you should add some really fine diffuse, aka base color variations for the wrinkles. The really great thing about this is that we already have a node setup for it and everything. We just need to switch 3 images. So we can copy the full node group, and yes, it's going to work with diffuse maps as well. But first I'm going to plug my height map back in normal so you can see it's working as it should. Okay, now at the base color, I'm using ambient occlusion as well. If you do as well, leave this to the end of the node setup. But I'm not going to copy the nodes just yet. Let's create the diffuse maps first. Obviously, we don't want to mess around with our main diffuse color. You can do that. It's really fast and cheap way of doing it. You just paint on it and save it down separately, but it will be a bit problematic. I want a way bigger control on it. So for that, I'm going to show you a technique on how to create a paint layer, just like in Substance Painter. As I believe there is some add-on for it out there, but you can easily do it inside Blender in a few seconds. So for that, open up two windows, a shader and a UV one. In the UV, create a new image. Call it, for example, base color / forehead / layer, or whatever you want it. Set the resolution to whatever your base color resolution is. Mine is 4K, so I'm going to use that. Make sure to check in alpha, and here in the color, find this alpha slider and make it 0, and now create it. What this will does is it creates us a full transparent base. This is exactly what we need. In the shader tab, if you have an AO, just unplug it and use only the base color, like I am doing here. Make some space here before the material output and get a mix shader. Get a diffuse BSDF from that, add an image texture. Here, select the texture we just created, plug in the original principal BSDF to the first socket of the mix shader, and plug in the new BSDF to the second socket. And now it's really important that you should get your alpha here and plug it into the factor of the mix shader. And now if you connect it all together, we successfully created a paint layer. Go into texture paint mode, select the image, and find the texture we created. Once you have it, if you are in normal viewport shading, you won't see anything. Let's select paint soft now and paint something. You can see it's like the invisible man. Okay, cool. Seems useless in this form. But if we change the viewport to a material preview, now we can actually see our base texture. And now we can start to paint. First of all, pose our character in a way that all the wrinkles are visible in the forehead. Once we have that, we obviously don't want that huge paint stroke here. So to remove the paint, select Erase Alpha here instead of Mix and paint the area. Now we can go back to mix and select a brownish, reddish, darkish color or whatever fits for your character. Look at references for that matter. We want the strength to be really minimal. We don't want the diffuse map to dominate. We just want some really light strokes here and there to enhance the realism of the normal map and the overall look. Basically, this is what it's good for. So lightly brush it in the creases. Usually on the top of the wrinkle, you can light it up with a little bit of white to emphasize that the blood has flown out of these parts. It's more recognizable and visible in the nose area usually. I prefer to use a lot of smear and blur for this to tone it even more down and make it really subtle, but this is really up to you. If you don't like your overall color scheme you picked in the beginning, you can use a mix color node here with a color ramp or whatever you want to color correct the part. So I'm going to use a little bit of reddish color here. Seems okay. Now once you are satisfied with it, go to image and hit save as and store this image. If you want to change something, you have to come to this image. Now let's create a new image on which we will bake and combine this whole texture. Create a texture size of your base normal texture, which in my case is 4K. Alpha can be 1. Now it doesn't really matter now. Name it, for example, BC_WMK_forehead. Just make sure alpha is selected. Now it's a really important thing before we bake. Get a diffuse BSDF and change the principled one. We don't want anything from the principled BSDF to compromise our diffuse map. So that's why we need to switch this temporarily for the bake. I don't recommend to skip this step. Now let's go down and select diffuse again, no direct and indirect. In the shader, get an image texture and select the texture. Now let's hit bake. And now as you can see, this is successfully combined the two diffuse maps into one. Now hopefully it's pretty straightforward from here. We need to do the same process for the nose and the mouth as well. These are what I ended up with. It's not perfect, but you can take as many time with it as you like to make it way more awesome than this. For the neck, I didn't do any diffuse since I didn't felt it's necessary, but you can add it if you want to. Now let's duplicate that node tree. Hit the little icon to make it a separate group so we can modify the textures in it. Let's change the three textures and connect it up just like normal. And for the AO, if you have one, plug it into the end of the groups. And that's it, we are done with it, at least for solely Blender users. I hope you found this helpful, and I'm thankful if you stick around for this far. But if you want to know how to implement this to a game, then hang a little bit more and I will about to show you. Everyone else who is here for the Unreal part, get ready because we are not going anywhere from Blender. Well, at least for a few minutes. We will have to do some extra tiny thing here first, which you can do inside Unreal as well, but it's way easier and logical. And do it my way and do it right here. This thing is vital in order for things to work, and I will tell you why when we are inside Unreal. The only thing we need to do here is to create some additional shape keys. Let's get into the shader as well. Remember what I said? Really important to call them the right name. Check it twice, check it 3 times, check it 4 times. Now if you didn't, well, it's going to be a pain for you, but for the rest, it's easy. So what we want basically is a full and a total duplicate of this shape key and driver as a new shape key with a different name. I will show you. Let's create one and call it WM, like as Wrinkle mask, / bro outer up / R. Now copy the driver and paste it. And now if I leave the bro upper up right, you can see it mimics it. This is exactly what we need. And that's what we need to do on all of the drivers we set it up, except for the neck. If you remember, it is driven by bone, not a facial one. So we don't need a shape key for it. We will set it up in Unreal exactly the same with basically bone-driven driver. So a quick jump, and this is all the drivers I created with a copied function. Pay attention to the naming. It is really important that they should contain the exact name of the shape key. In a way you can find it. In cases like the forehead where I have one shape key, brow inner up, for 2 drivers, I name them logically left and right. And as well in the case of mouse smile, since I use mouse smile in both nose map and mouse map. I call it WM nose mouse smile right, and the mouse one WM mouse smile right. Now once that's done, you need to export the character and the animation you created. In my case, that is the FaceROM. So here we are at Unreal. If you already had a character, just right click and hit re-import with a new file and find the file you created. This way you will get the newly created shape keys / more targets. So this is the setup. I think you already got that if you click on this video. If you are not sure how to set up these, I have videos about it on the channel. If you made it through the Blender section, good news. The node setup in Unreal is going to feel familiar. Well, sort of. We'll be referencing some of the earlier steps to help you logically locked on this track, but keep in mind, since this is Unreal, a few nodes will look and behave a bit differently. So there will be a few changes. Just in case, I would like to mention these few nodes here to avoid confusion. So these ones here are just the same as was in Blender. So it's my height map. So just like in Blender, I'm going to unplug my height map now. And again, let's just focus first on the normals. In this case, this is the blend angle corrected normals. It's different than a bump node there, but it's extremely simple terms. In my case, it's doing a combination for both maps. Don't get confused also with the virtual textures. You don't want to use them here, and I recommend never ever try to mix virtual textures with regular ones under one material, since it will cause you a lot of crashes. I have that here, but that's BS. It's left from my Addon workflow, and this combination will cause me a lot of crashes while I record the tutorial. What you want is either full virtual textures or just simple textures. So in my character, I have material called skin mi. That means that I already have an existing material from which I created a material instance. In order for this whole thing to work, you need to create a material instance out of your material. To do that, just right click and create a material instance. Then replace your material with the material instance. First and foremost, some Unreal logic and math so you understand better what's going on. Let me show you what's happening in this material example. I added 2 different images / color constants here. Everything you see in the material, whatever it's a color, a texture, or a special effect, comes down to numbers. In computer graphics, a texture isn't just an image, it's a grid of pixels, and each pixel holds a numeric value for red, green, and blue channels, usually between 0 and 1. For example, these constant nodes here are just giving us specific RGB values, literal numbers we control directly. Think of this as just one simple pixel. Now, since they are just numbers, we can do math on them. Take a look at this add node. What it's doing is exactly what it sounds like. It's taking two sets of numbers and adding them together. And if we add these two numbers on each channel together and get another constant and type this in, this will 100% will be the same color as the added one. But we want the first constant color value back, because that would result a washed up texture in our character if we just keep adding extra numbers on each other. Well, this would be easy. Just use a subtract node from the whole and voila, simple math. Now let's see the same logic with actual textures. So here is the two texture. One has a simple stroke of red on it. Their color range otherwise the same. So let's use the logic here again. Okay, it does the same, but now I realize that I want that red stroke. That red stroke should be visible, because that's supposed to be the wrinkle map. Then this logic will not be suitable for us. How about if I'm going to use subtract before the add node? And subtract the base color from the red stroke color. Now plug it in. And now that's what we want. But we want to control the strength of the second map. So let's add a multiply node here and connect them up. Okay, now we control the strength. Basically like that, we created the first mix node, just like in Blender. The only thing we need to do is to set up the logic for that B socket to work according to the mask we have, just like in Blender. But first, set up the basic logic in our character material. Let's start with the normals. So import and drop in all your normals in the shader. So I have one base, one for the forehead, the nose, the mouth, and the neck. Let's do the same logic. So let's get 4 subtract node and plug the base to the B of each. Now for the first A socket goes the forehead, second the nose, third the mouth, and for the fourth one the neck. Let's add 4 multiply nodes with value 0 on the B and connect them up like so. And now that we have multiplied textures, we need to add them together first. So get 3 add node, first multiply to the A, second multiply to the B. From this add node, connect it to the other add node's A socket, and the next multiply result to the B socket. Same thing for the last one, and get yet another add node. And this time plug the base normal to the A, and for the B socket, use the add node's output and connect it up. Now this again feels similar as I mentioned in Blender, if you remember. We don't want to mix our base normal map anymore. We did it at the first node, we don't need any more of it. It's just backwards. Now let's see the logic for the mask. So the great thing in Unreal is rarely, but sometimes you can simplify things like masks. So we don't have to put every map here. Instead, we can create a texture array, which stores all of our masks at once. So let's do that now. I created a separate folder for the wrinkles. You should do that too. Right click on the content browser and search for texture array. Name it and get inside of it. With this button, source texture, you can add new slots. I have a total of 9 maps, so I'm going to add 9. You can add just 8 if you use 0, but that's just a personal preference. I feel it more logical this way if I leave 0 empty. Now the index right here is going to matter. So I want to place the mask in a logical order. I don't want to confuse myself, so I'm using the same exact lineup, just like in Blender. So forehead right, forehead left, nose right, nose left, mouse maps, 1, 2, 3, 4, and the neck for the last one. But sometimes this is bugging, I guess because I leave out 0, and it vanishes my last slot. To fix that, I just select the neck for 0, so it has something, add another slot, place the neck, then remove the texture from the 0. And if you're worried about this up here, it's not going to affect anything. It's just a warning that we should optimize this with bitmaps, setting different texture groups for it and so on. But that's not important right now. Now we can save this, keep this open for now. In the shader, get 3 constants while holding 1 and left click, or look it up here. Convert them to a parameter by right click on them and hit this. Name them 1, 2, 3 for now. Look for a node named makeFloat3. Now there is a version makeFloat2 and 4. These are basically just holds together various parameter numbers for each channel. makeFloat4 contains alpha as well. If you really have a lot of wrinkles, You can use alpha as an additional layer besides the red, green, blue. I didn't cover that. I wanted to make this an easily understandable tutorial, but you can do that as well. I might do a short on it later and link it here if needed. But currently we are just going to use float 3. We have 3 values, red, green and blue. Let's pull this way down so we have more space. Now here it gets a bit complicated. Get a saturate node, a dot product node, and a simple constant with a value of 1. You don't have to convert this to a parameter. Connect them up like so. With this we are clamping the values between 0 and 1, so it cannot go crazy. Let's get an if node from that. Now we have to decide what will happen in these 3 scenarios. If the A is bigger than B, which means it's more than 0, for that get yet another dot product from the saturate node. And for the B, we are going to use our mask array, which we just created. Drop it into the shader. If you are using make float 4 node, then you should connect the RGBA channel. But we are using just float 3, so therefore we will only need the RGB. So that's what I'm going to connect. From the UV, pull out an append node. For that append's A socket, we want the texture coordinate. And for the B, we want a simple constant. Now this constant number will reflect the index here in the array. This is a mask picker number to make it easier to understand. So I want the forehead right, which is index 1. So I'm going to type in the value 1 to the constant. And now finally we need to decide what do we want to happen if they are equal or when the A is smaller than B, which would result in a minus. Well, we don't want anything to happen since we don't have a logic for minus shape keys, and we don't want anything to happen when they are equal, so when they are 0. Therefore, just get a constant and type in a value of 0, then plug it in to both of them. Don't worry, this was the hardest part. Okay, cool, let's save this and see what it does. So open your character, besides that, the material instance, and let's crank up these up, for example. Okay, looking cool, doing exactly what it should. Now we are exactly at the part, just like in Blender, how to automate this instead of manually changing. You might ask, we have more targets here, which are the shape keys in Blender. Can't we just cramp that one in somehow? Well, yes and no. Unreal has its own method for this, which are curves. Give me a few minutes and you will get it. So curves. Wait, there are no curves here. Should we add? The answer is no, we should not. But how about the skeleton of the character? If I click on this, it brings me to the skeleton. My skeleton is the Unreal one, but it doesn't matter, it can be a custom one as well. And now as you can see, here it has a bunch of curves. Most of them comes from Unreal own setup, and these curves currently not important to us. What matters are our own curves, because each shape key, aka morph target we have, must have a corresponding curve for it here as well. There are 2 types of curves. If you have hover over here, you can see one says morph target, aka shape keys, and the other one says material. This can be either or, so it cannot be both at the same time. So one can neither or just morph target or just material. There is no in between. That's important. But what actually are curves? For further understanding, let's open up the animation of mine now. Now you can see there are a bunch of curves. Click on the windows and click on Curve Debugger. Now you can see the same stuff like at the skeleton. We have filters here for active morph target and material. The active, obviously, the active ones that animation currently use. If we untick it, we can see all the curves that exist on the character. You can see that we can edit the curves here as well, remove them, and so on. Let's go into nose near left. So this curve shows what we keyframed in Blender. Now you might say I ain't shape keyed, nothing like that. Well, if you have a hard time wrap around your head for these curves, let me show you something. I'm going to pull in my Blender here, NLA, start editing action. This window is a graph editor. Let's find that nose near left. And I believe it's moving on the Y location. So let me just hit all except that. Now ain't you look at the cheeky wanker, it's exactly the same as here. So we indeed keyed like that. And what was the first thing I said to do in Blender before Unreal? Is to create these mimicking shape keys. Therefore we already have all the necessary curves that can be changed to a material with a few clicks here at the skeleton. As I said, it only can be one, never both. That's why we need those shape keys. As I said, you can do this in Unreal, but it's much more annoying and way easier in Blender. But if you didn't listen and didn't create the shape keys in Blender, what you have to do is go to the skeleton, add the curve, and name it whatever you want. Just make sure you find it. Save it. Now here at your animation, go to the top, click on this add curve. Here you can see all the curves you have. Get your newly created curve. Now it's on the bottom. Find the curve that it should mimic. Click on it, edit curve, select all key, copy them, close this, get into the new curve and paste it. As I said, it's problematic, but there you have it. Now it's cool and everything, but you still don't know how this is going to affect our material. Well, now we have to set all the mimicking shape keys to material, so do that now. And here comes the fun part. Since Unreal Animation curves can automatically affect scalar material parameters, which we already have in the material instance, the only thing we need to do to make this work is to match the curve names to the name of the material parameter in the material. From the skeleton up here, you can easily copy and paste it to the scalar parameter name. But take a close look on what you're copying, make sure everything matches, so watch the sockets. So the first one is red, brow inner up, right. The green is the brow outer up, right. The blue is the brown down, right. Save it down, and let's check the animation now. And there it is, it's awesome. Now start organizing this a bit. So just like in Blender, we are going to group things slowly. So here it's called material function instead of group. You can create one from scratch or just select all this, then collapse to a function. Create a material function folder, name it something like that represents that this is a texture sampler function. Now copy these, change the index to 2, the second one, which is the forehead left mask, and replace the names of the parameters with the corresponding left version. Get an add node and connect them up like so, and connect it back up here. Test it, it's awesome. Now there is one important thing which can cause us trouble later, so let's get into that material function and change this to vector 3 to properly match the input. If you're using make float 4, then you should select 4. While we are here, we can rename the other input as well to mask number. Save it. Now in the shader, let's collapse this as well to a function. Call it forehead_mf. Now in the content browser, let's duplicate that forehead function and name it nose instead. Get inside the node and replace the needed values. So the two parameters, 3 and 4, so right and left nose mask. Get the corresponding names. Plug it in, test it, and it just works. Now duplicate it again. Now for the mouse, I'm going to skip ahead since you already know the logic, and this is how I ended up adding them together. Okay, so let's get into the neck. We want this to be more dynamic than the others since they are limited to the face area. The neck rotation in the game can be moved by a variety of different movements, and we don't want to get the curve for each and every animation separately. So therefore we will do it just like that in Blender, make the material driven by a bone rotation. And we are going to do that in a post-process animation blueprint, which I already have. If you're not familiar with it, this is where I set up the jiggle and hair physics. You can check my channel for these tutorials, but there is a short video for it to sum it up for you. So once you are here, you should look for a bone driver controller. At the source bone, you should look for the bone that should influence the material. In my case, as you know by now, this is the head bone. Source component is where it's going to narrow it down on which axis should it influence it. Just like in Blender, as local space, I should use X-axis. If you're not sure on which axis you need, go to the skeletal mesh of yours, find the bone and rotate it and check it. It is the X indeed, so I'm going with that. Next is destination mode. Here we can select what do we want to drive. So we want a material parameter. Select that and now we have to give a name for it. But what name should this be? For that, now we actually need to create a curve on the skeleton now. So go to the skeleton and hit add curve. I will need 3 curves for each mask part, so red, green and blue. So I'm going to call them WM_neck_right, WM_neck_left, WM_neck_down. Change all these 3 to material curve as well, save it down. And now we actually have a name we can write in the post-process blueprint. So let's start with the right one and plug it into the output pose. And let's head to the skeletal mesh and test it out. Nothing happens, well, because we didn't yet do the scalar setup for the neck inside the material, so it doesn't have anything to drive. Let's do that now quickly. Duplicate the material function, simplify it to one mask, since I only have one, change the mask index, and change the names for the corresponding curves we just created. And now test it. Well, it's working, but it's kind of weird. It appears right as I rotate it. That's not exactly what we want with it. We want it to slowly pop out. For that, let's create a new folder and name it curves. Right click on the content browser and look for curve. Hit it, select curve float, name it for example right_c as curve. Right click here and add the key. We want this to here to be 0 and 0, which means when the head didn't rotate, then the value is 0. Now click here, add a key. Now here let's type in 30 and 1. So if you remember in Blender, I set the driver exactly like this with the script. Head rotates on the x-axis by 30, between 0 and 1. Right click on the keyframe and select Auto to smooth out the curve. So I'm going to save this now and close it. In the post-process blueprint, there is this section called mapping, and here it is a driving curve. Instead of remapping it with this, I give this a very specific thing I want to do with this via curve. So here I'm going to select that curve and see how this works. Compile, and voila, it's working great. Now do the same thing, and for the other side of the curve, we want the second key to be -30, just like in Blender. Do the down version as well, and now all of them working great. This neck movement is visible here in the skeletal mesh preview because it is a post-process blueprint and it's running under it. If I disable it, it's not going to be visible. If you want to implement this logic into the main animation blueprint, this will be not visible here, just in the game. This applies to the facial animations. Facial animations wrinkles will be visible in game, but not in a preview here. In short terms, because this is not how it works. This is also good to know that these two are two separate things. Basically, the neck is full dynamic, where the wrinkles are driven by animation curves. And these curves driven by animation data we created in Blender. If you don't have the animation data, that means we don't have a curve data. Also good to notice that where the copy factor is automated in Blender, it is not here in Unreal Engine. If you are looking for that, you will need to do heavy blueprinting and basically want to create a face controller inside the engine, which is really hectic if you want to do that. And at this point, I don't see any value of it since I can just animate whatever I want inside Blender, and it's going to work perfectly here in Unreal from now on. In the future, I might do a tutorial on a face control rig here in Unreal, but not anytime soon. Now let's finally group all of this together and collapse it into a function and call it animated wrinkle maps material function. Some spaghettification is happening, so let's get inside the function, and we want to fix that wonkiness there, so they are in the right order. You can do that by sort priority, but first let's align them correctly. Let's name them as well. So first one is base, and write in sort priority 0. Next is forehead, set the sort priority to 10. After that, nose, sort priority to 20. And the other seams, they are in line. I will just change the names. Forehead, nose, mouth, and neck. Now it's looking much more tidy. Let's just drop it here. For the diffuse, get your diffuse map, connect them up logically. I should have created a separate version for the neck, because if I leave this unplugged, it will give me an error. But I'm just going to plug in my base normal here, and I solved that issue. Let's test it out, and it's working as it should. And that's a wrap for today. We successfully set it up a perfect wrinkle system inside Blender and Unreal. It was a long one, so if you made it all the way through, thank you so much for sticking with me. I really hope this tutorial helped you out. If it did, please consider leaving a like, subscribe, and I will see you on the next one.